So we're Team 31, the Assist CO2 Monitor. I'm Alex Hutchins, and I worked on the sensor implementation and all the data processing.
Hi, my name is Xiaohong Gu. I'm overall system integrator as well as hardware enclosure designer.
Hi, my name is Mai Sawada. I was responsible for mostly software design. I implemented the graphic and also the numeric mode to show the ETCO2 values.
And my name is Yang Yue, and I'm mainly working on the power system and also the user interface.
So current CO2 monitors for EMTs are extremely bulky, and they're heavy, and they're prone to damage. So we've implemented a similar system in a compact and portable design. As you can see here, it fits in the palm of my hand instead of, maybe possibly using two hands to carry. So our device measures CO2 output, and it can tell whether you're breathing or not, and then also the exact concentration of CO2 in your breath. And this is used to help determine how well your lungs are oxygenating your blood.
Our device is a low power device, so we utilize a MSP430 microcontroller communicating with a infrared CO2 device and an LCD output device. So you can see right here, actually I have a exploded view here. Here's our sensor attached to the breathe tube. Hold on. Here's a breathe tube, and then the sensor go attached onto it. And then here's our microcontroller board that's attached to the sensor. And this is the final product. So during the patient resuscitation, you put the device onto the patient, and from here you can see the CO2 level. If the patient is breathing, that means there's actually a waveform going on. So the biggest challenge we have for our project is to design the right breathe way to incorporate the sensor and the LCD assembly, but also provide enough flow rate to the sensor to detect the CO2. So you see we have all these different iterations of breathe tube pretty much that we made over the course of 2 semesters, and this is our first one, and you can see it's very bulky and doesn't really flow that well. So at the end we made this is our current design, and we have a choke in the breathe tube that will force the air into the sensing chamber, whichever direction whether you're inhaling or exhaling. When you're exhaling, the pressure over here will be greater, which will force the air into the breather tube and vice versa.
So one project management skill that we found particularly important was staying in continuous communication. We constantly chatted through a group message, and we always had a weekly meetings on Friday that we would discuss our current progress and our future plans for the next week, and possibly next few weeks.